how to do the keys to it, everything?
Yeah, a big part of the test tomorrow is going to be graphing. So typing in like stuff in the window, the T-min, the T-max, and that kind of
Just
stuff.
refresh on all those things, yeah, I'll just get those in the sheet.
So let's just take a look at a parametric equation. Do I need to type both of those in for a parametric equation, or just one of them? Both. And I'm just going to make something up, and I'm not exactly sure how it's going to look, but we'll just try it and see what happens. So let's let x of t be 3t plus 4, and let's let y of t be t squared. All right, so in order to graph that, the first thing I have to do is put the calculator in parametric. So press mode, okay, go to parametric, and now you're ready to type it in. Okay, we're going to type each of those in the same spot. We'll put them both in the blue, or same equation. So we got 3t plus 4. And notice now the x button turns into t once you make it parametric. And t squared. Now, there's one other thing you need to be able to graph that. They got to tell me one more thing. What else do I need to know? Something you have to put in under the window.
Oh, the zoom first?
Not the zoom, but something else that's in that window. Might have to adjust the mins and maxes for the x min, x max, y min, y max, but there's something else there.
Oh, is it
The t step, the t min, the t max. So you have to know the interval. What do they want me to graph this? From what to what? So let's set our interval, well, the y's are going to get pretty big quickly. So even if t is only 0 to 6, y is going to be up at 36.
So this is just like you're just kind of guessing this off the top.
I don't know what it's going to really look like. I'd have to figure that out.
But you're just giving like an estimate to find it. It's not.
It's going to be a parabola, now that I look at it. Yeah, it would be a parabola. But yeah, I got to kind of figure out my mins and maxes. So for my y max, I should go at least to 36. Because if the biggest t can get is 6, y is going to hit 36 at some point. And the smallest would be 0. So you should set your min and max for the y's. Let's go 0 to 40. And if t is 6, what's the biggest, bless you, what's the biggest x value you could get?
Biggest x value. 40.
Goes 22.
Not that big. Not 20 what? Yeah, so you could go to 25. That's probably good enough. And what about the smallest?
4.
Yeah, you go to 4, so actually leaving x min at 0 is probably fine. So that should be a good window that shows us our graph. So you're getting part of a parabola. Notice your smallest x value. Kind of hard to see, but it is at 4. If I went a little lower, like -5, then you definitely see that it doesn't go below the axis. It stops.
Quick question. How would you know for this particular problem to set it to parametric? What are you looking for in a problem to set it to parametric?
Anybody answer that? How do you know that's parametric?
T.
Yeah, you get t's in there. Anytime you have t as the variable, it's parametric. And you have a separate x and y equation. So anytime you have a separate x and a y, you got to put it in parametric. Now, if we were to graph something with sine, okay, anytime we use sine, what does t have to go from in order to get a full picture?
From -1 to 1, right?
Not -1 to 1. So t is what you plug in. So t is an angle. So, yeah.
90?
That's one of the numbers that's between the two that I'm thinking of. It's in the middle of them.
So 180.
There's another number in there.
0 to 180.
Not 0 to 180.
Is this are you saying what's the max it can?
I'm saying, what would you have to let t go from to what? From what to what?
0 degrees to 30 to 60 degrees.
You got to go 0 to 360 to get a full picture. All right, so if we did something like this, this one I'm not really sure what this is going to look like, but you've got to let t go 0 to 360 if you're in degrees. But what about the way I'm set up right now? Not 0 to 360.
And it doesn't go all the way. Are you in radians?
I'm in radians.
Yeah.
So what should I go to?
Because you have degrees.
2 pi. So whatever I'm going to get, that'll give me a full picture, going 0 to 2 pi. Let's start with a standard window. Let's go zoom 6. Okay, and it seems like, just going to zoom in a little bit. Seems kind of like we're just getting a circle, okay, which I think we talked a little bit about circles.
You can use zoom square, right, and make it a complete circle?
Yep, you could use zoom square. And now we get a circle. Okay, if you switch those, okay, I just kind of want to see what happens if you switch them. I don't know if you still get a circle.
You do.
Oh, you do?
Direction.
Yep. Okay, so just make sure that you let your parameter go all the way as high as it needs to. And with trig functions, that's always 0 to 2 pi. If you did something like this, 0 to 5, you're not going to get a full picture. It's going to stop. Okay. Also, what about the t-step? What do you have to be careful of with that, especially when you're graphing something that's curved?
Not too small.
Yeah, it can't be too small. Like if you go by ones, it's going to look kind of like a hexagon or something here. Okay, it's not enough detail. I would say 0.1 is probably good enough that you get enough points and it looks pretty smooth. Okay.
Yeah, but you also don't want to have it, if it's too small, it takes forever to like load up, right?
Yeah.
Like, you have to like calculate every single one of the points and stuff.
Yeah, if you made it like 0.001, then it's going to go from 0 to 6 counting by 0.001. That's going to take a really long time. And your calculator will probably overheat and battery acid will leak out. So don't do that. Okay. So
So for the,
questions on that?
could you go back to the original, like what the original two that you scanned? Yeah, the white.
Yep. Third was first. Circle.
Yeah. How would you know? Did you just literally graph those 2 points and then went in and switched to try to find the table, or did you already know the table? What table was going to be?
I'm not sure. What do you mean by table?
Or you went to the window. I meant window.
The window?
Yeah. So it's like so those are the 2 points, and you go to window. How exactly do you know when to switch?
Well, for this one, especially the way I had it before, we studied this. That's the equations of a circle.
Okay.
So if you don't have a number in front, it's a 1. So we know that that's a circle with a radius of 1.
Okay.
So that would tell me to set my window at least -2 to 2 and -2 to 2. If you did something like this, now you're graphing a circle with a radius of 3, I would go -5 to 5, -5 to 5. But the only reason I would know that is because I know that's a circle with a radius of 3. So now it's going off the screen. And it doesn't quite connect there because of my t-step. My t-step is not, it's not a multiple of 6.28. If you set your t-step a little smaller, you will get less of a gap. It's going to take a little longer to draw it, but I don't think you'll see as much of a gap now. Okay. So what I'll probably do is give you a set of equations like this on the test. You're going to have to figure out what you need to set t to in order to get a complete picture. So if it's sine or cosine, you already know 0 to 2 pi. And then I'll give you some choices to match it up. Okay? So you're not going to have to do the reverse. It's pretty hard if I give you a picture and you have to figure out the equation. That's really, really hard. But I'll give you equations and you're going to have to graph them and pick the one that matches. Okay, so make sure you know that. Another thing you want to make sure you know how to do is type in things to higher powers. Like, let's say I wanted you to type in cosine squared. Okay, just we'll make it simple, cosine squared. The way you do that is you put cosine in parentheses and you square it. Okay, I think we've done that before.
Yeah.
And then you could hit graph, and you could see what kind of shape you get.
Oh.
So I have to zoom out. It looked like it kind of drew it in two directions, like it started going up, and then I think it traced back over itself and it went down. I could kind of see it tracing back over it.
Mr. Hager, what happens if you have like an inverse sine or an inverse cosine? Does it go in the opposite direction?
You get something totally different. Yeah.
It's a different value.
It's a different function. Yeah. But you could try if you want to try it, like inverse cosine t. So just kind of like that little curve. Yeah. Okay. So any questions on how to type in a trig function to a higher power? Again, I think we've done it. The key is just make sure you put it in parentheses. All right. Next thing. Actually, let's take these equations right here, and I want to eliminate the parameter. What does that mean to do? Eliminate the parameter. Well, what's the parameter there? T. So eliminate the parameter means I want you to rewrite that without t. So 2 steps. Anybody remember how we do that?
You have to make it equal to t?
Okay, you have to solve one of these equations for t. Do you remember which one we solved, the x equals or the y equals? The x equals. So if you solve that equation for t, you can just pretend that that's an x. It's the same thing as x of t. What would t equal if you got t by itself here? What would you have to do?
X over 3, right?
Um,
Times 3.
well, what would you do first before you did the divide by 3?
Subtract 4.
Subtract the 4. And then
Over 3.
divide by 3. So over 3, over 3. Yeah, you can put the 1 in front and make it 1/3 x. And now, what do you do with this?
You plug that into the other one.
Yep, for what letter? T. So you're going to fill that in, and that's going to eliminate the parameter. So you get y equals, we're going to have 1/3 x, which you can write like that, it's the same thing, minus 4/3 squared. That's your equation.
It's kind of like when we did it like f of x and g of x, right, Mr. Hager, where you substitute 1.
Yeah, kind of like that, you plug one into the other, yep.
It's all math.
Now, there's one more thing you have to say about this, because the original picture, did it go on forever?
No.
No. Okay, it was limited. I didn't write down the limits, but let's just say the original problem went from 0 to 4. I think we did 0 to 6, but we can do 0 to 4. So that means this problem also needs a restriction, okay? Some kind of restriction. How do you figure out what the restriction should be?
Oh, is that these little formula, right?
Don't you should plug in?
Well, everything's right there that you need. The formula is up there.
Do you plug in numbers for x, like a 0 for x, and then that would be minimum, and then you put in,
Well, you don't plug in numbers for x. What are these two on the calculators? If you went to window, what's the 0?
x.
No, 0 is not x.
0 is the middle point, the center, right?
Well, what does the calculator call it? Like if you go to window, t-min. That's a minimum t value, and that one is
Oh, maximum t value.
a maximum t. But when you write the domain of the final answer, it doesn't have t in it anymore, it has x. So where could you plug these two numbers in to figure out the two x values?
Through x?
into the line, into the new equation before we plug in 0 and plug in 4?
Well, remember, these are t's, right? So these have to take the place of t.
You would do it
Yeah.
in the original?
In the original.
Okay. I remember that. I remember going back in.
Those two numbers are going to take the place of t. So start with your t min. What would you get if you plug in 0?
4.
4? And what if you plug in t max?
16.
16. So when you sketch this picture, you're only sketching it from 4 to 16 on the x-axis. You don't go before 4 and you don't go after 16.
So when you find the T min and the T max, right? Oh, so wait.
Yeah, that would be given to you.
Oh, okay.
That would be given to you. Okay, you don't have to find
Yes,
that.
you have to find that.
Yeah, they'd have to tell you what the t min and max are, and they have to tell you the x and y equals equations.
So when you're eliminating the parameter, right, you're actually finding what it can be in between, not what it like what it actually is, right? Because there could be many different values for x, right?
There could be. Yep, and you can pick anything between 4 and 16.
Okay.
So how do you know it was 0 and 4?
That was given.
Oh.
Yeah.
Oh, okay. So
Okay.
it will be given?
So that'll be given, yeah. And now when you graph this, you can only pick numbers for x between 4 and 16. Like you can't plug in 0 for x. If there wasn't the restriction, you could. But our original problem had a restriction, so does the final answer. Okay, there's going to be a couple problems where you need to eliminate the parameter and possibly tell me the restriction after you do that.
Are there any problems that are just fine, the y? Or will all of them have restrictions?
Well, if they give you a t min and a t max, then there's a restriction.
Okay.
If they don't give you a t min and a t max, that means t can be anything, which means x can be anything.
So it's a kind of point, okay,
Yeah.
I got you.
If there's no interval, no t min, no t max, then you don't have to worry about writing a restriction. Because there wasn't a restriction.
You just stick to the line, okay.
Yep. All right, so there'll be a couple of those, okay, eliminating the parameter. And the other thing is, you should be able to FOIL something out like that. I mean, this one's a little messy because it's fractions, but if you had something like that, any questions on how to multiply that out? If you had to?
It's x squared plus 4. Or factored out would be x squared parentheses, x plus 2 parentheses, x plus 2.
And then if you did all that out,
Then, okay, then you would get, okay, I got you.
what would you get here?
You get x squared plus 4.
No, you would get
Oh, no, you have to
x
get
plus 2
No,
times
I
x.
just did twice, you just distributed it.
Yeah, you gotta go.
You
X
have the same thing.
squared would be x plus 2.
You get x squared plus 4x plus 4.
Yes. Okay, so that's going to come up. You just can make sure you know how to FOIL that out. All right. What's that? No, I never said you were. Okay, graphing a little bit more in parametric. Again, no questions on how to type in the x, the y, the t min, t max. That's okay? Okay, so we'll have that. Let's see. We'll also have the test is going to be in 2 parts. Not because it's really long, just it's 4 pages and I only photocopied 2, and then I realized I didn't do half the test. So it's the separate pages. Graphing. So the next thing we did was graphing things in polar. So graph, and let's say we had something like 2, 210 degrees. Now, if they don't give you a circular grid to graph on, let's say they just give you a grid like this. Well, we don't need 2 of them. 1 is sufficient. So they give us a grid. you can still graph that on here. Okay? What you could do is if you want to see kind of where the angles would be or where the circles would be, you can sketch your own circles. Okay? There's a circle of radius 1, and there's a circle of radius 2. Just draw it in yourself. All right. And now how would I graph 2, 210?
So you go right 2,
Right 2,
and then go counterclockwise 210 degrees.
and then counterclockwise 210. So halfway would be,
That'd be 180, and then so you're going to be like a little bit before, or like kind of in the middle almost.
right in the middle?
A little bit less than
Yeah.
that right there.
So you got to go 180, and then you got to go 30 degrees more. And that's how you graph that. There's 4 different points you could have. 2 positive, 2 negatives, or positive, negative, negative, positive. Any question on how you'd graph something that has a negative in either spot?
When it's a negative degrees, you just go clockwise, right?
Yeah, so how would you graph that one?
You go clockwise 90 degrees from point 1.
Yeah. So if you want to graph that one, you go clockwise 90 degrees after you go right 1. You'd be right there. Okay, how about if you had a negative radius? So let's go like -1, -90. I just don't want it to land on the same spot. Okay, so what would happen here?
Well, you grab the negative, look at -1 to the left,
Okay, so you go left 1. Yep.
and then counterclockwise at 90 degrees. I mean clockwise.
Clockwise. Yep. So you're going clockwise. So you'd be right there. Okay. And you could also have the same thing in radians. If the radians confuse you, you could always change radians to degrees. Okay. Any questions on how to change radians to degrees?
Yeah, could you do that?
So what if you had an angle of 4 pi over 3? How do you convert that to degrees? Brett?
You multiply it by 80 over pi.
Yep. 180 over pi. And 3 goes into 180.
60.
How many? 60. And then you're left with 4 times 60. So the answer here is 240.
So you're pretty much just trying to cancel out the pi
Yep. You always multiply by 180 and divide by pi to convert radians to degrees.
every time. Okay.
Yep. Degrees to radians, you flip it. It's the other way around. Okay, next thing is I'm going to give you a rectangular coordinate and ask you to convert it to polar. So let's say we had something like 5, 200, I don't know, 215 degrees. Okay. When you have a coordinate in polar, what are the 2 things that they give you? If that's polar.
What are those things they give you in polar? They
Yeah.
give you radius. And
Radius
theta.
and theta. And if you're trying to change to rectangular, what are the 2 things you want?
X and Y.
You want x and y. Okay, so we actually reviewed this today. What's the formula for x?
And what specifically is this called one more time?
This is changing polar to rectangular. A coordinate.
It's like almost finding base. It's like a, what do you call it? Pythagorean theorem, right? So you have the radius, right? And then all you have to do is find the y and then the x, right? And you have the theta, right? So you could use like Sakatoa
Yep.
And that to find out.
So you could figure it out, or if you have it memorized, because that's how we figured out what the formula is, we use this, the SOHCAHTOA. Does anyone remember what the formula for x was?
Was it sine? Or was it cosine?
Cosine, that was part of it.
Cosine, cosine.
R cosine theta. And what about for y?
R sine.
Okay, so we just fill in what we have for r and theta. So x is going to be what in this case?
So x would be 5 cosine 215
15. And y?
and 5 sine.
Sine 215. Okay, so we just type those in and then see what we get. Okay, I gotta switch over to degrees because that's what I had. Right, so we got 5 cosine 215. That's negative 4.1. Okay, just rounding it off. And 5 sine 215. Negative 2.9. So roughly that's what the coordinate would be if you converted polar to rectangular. Now, there could be some special angles that come up. 215 is not a special angle. What would be, in general, what are the angles that are special? Luke?
45
Multiples of 45, any multiple, yep.
and 60,
30.
30. So you could have something like cosine of 30 come up. Okay, you might have to take the cosine of a 30-degree angle at some point. And you get 0.866. What is that? That's a special fraction.
That is, you said that 3 over 2 squared, or the square root of 3 over 2.
Root 3 over 2.
Yeah.
So if you take
You got it.
the square root of 3 and divide by 2, it's 0.866. So if you had something like, say you had to do 5 cosine 30, okay, to calculate an x value. What did we just say cosine of 30 was? Square root of 3 over 2. So this would be an x value of 5 root 3 over 2. Okay, so with anything that's a multiple of 30 or 45, you could do as an exact answer.
Is that a decimal in front, or is that just a straight?
That would just be 5 times. Yeah.
So you can either write it that way, or you can just write it 5 times cosine of 30, right? That's just a different way of doing it, right?
So if they're asking you to do this on the test, they are going to do that out.
Oh,
They're gonna do it out, either as a decimal, if it's not a multiple of 30 or 45, or an exact answer if it is. Okay, what about sine of 30? Well, that's an easy one, just 1/2 as a fraction. Okay, what about, let's do a 45, cosine of 225. What number is that? I don't remember how to write that one as a fraction.
Is that the pi one, or is that 3 pi?
No pi.
Root 2 over 2?
Yeah, it's the square root of 2 over 2. In this case, it's actually a negative. But 0.707 is the square root of 2 over 2. If it's a negative, you put a negative in front. Okay, so anything that's a multiple of 30 or 45, you're going to see fractions that are root 3 over 2, or you're going to see root 2 over 2.
So why is that a negative?
Why is it
It's
negative?
the negative part of the graph, right?
Yeah, think about 225 is in this quadrant. And remember that diagram we did? That tells us where the trig functions are positive. So if you're in the third quadrant, what's the only trig function that comes out positive? Tangent.
Yeah.
We're doing cosine. So cosine has to come out negative here. So would sine. If you type sine 225, you'd get a negative number. You wouldn't type tangent because tangent, that's not part of the formula. You don't need to worry about tangent. Just sines and cosines. So any questions on converting polar to rectangular?
I just, like, I get it and everything, I just don't understand, why, like, the last part that you explained about, what does that have to do with anything? Because like a lot of them just already, if it's not a multiple of 30 or a multiple of 90, or
45.
multiple of 45 rather, then it doesn't really matter.
Right, so all I'm saying is if you get a problem on the test that's a multiple of 30 or 45,
Yes.
they are not going to use decimals.
Not really does.
You're going to see square roots of 3 and square roots of 2.
Okay, okay.
If you get a problem that's an angle like 215, they will round that off to a decimal.
Okay, okay.
Because that is not a multiple of 30 or 45.
I got you now.
And a lot of the problems on the test are multiples of 30 and 45.
So you just, your options would, you would just be looking for one of those, you wouldn't be looking for a decimal, you'd be looking for.
Yeah, on a problem like that,
Yeah.
there wouldn't be any decimal choices at all.
Okay, dude, okay. Sounds
Yep.
good.
Everything would be square roots for your choices. So you just have to figure out the right ones.
Okay.
Now, the other way you can convert is from rectangular back to polar. So that's taking something with an x and a y and changing it to r and theta. Okay, so let's say we had the coordinate 2, 5. That's x and that's y. How do you get r if you know x and y? Yeah, it's the square root of x squared plus y squared. And basically that's the, yeah, it's, so all you're doing is you've got the point 2,5, that's 5, that's 2, find that. That's your radius. So in this case, the radius would be the square root of 29. Yep. If that was if you could reduce that, they would. So like if you got like square root of 20, you could break that down. Okay, but 29 you can't. Any questions on the radius?
Can you do the math for it out?
To do it out, yep, so it would be 5 squared plus 2 squared equals r squared. And then 25 plus 4 equals r squared. 25 and 4 is 29. And then take the square root of both sides.
Okay.
To find theta, I assume
Yep, now we got to find theta.
you have to use, like an inverse, right?
Yep, inverse tangent. And is this a quadrant where you add the 180 to it?
No.
No, that would only be in quadrants 2 and 3. Okay, if you're in quadrants 2 and 3, you got to put a 180 plus or pi plus if you're doing it in radians. Let's do this angle in radians. So we'll do inverse tangent of what would go on top.
5.
Yep, and over 2. Okay, so if I do this in radians, just switch to radians. So second inverse tangent of, I can just type 2.5. It's just as easy as typing 5 over 2. And I get 1.19 radians. Okay, so my final answer is square root 29. And do I need to label 1.19? Do I need to put RAD on it?
Do you put degrees on it?
That's not a degree, that one's a radian.
Oh.
So do I have to put RAD?
Yeah, because you can't put it as pi, right? You can't do it as 2 pi or 3 pi.
Well, there's no degree sign, so you can choose, and that's
Right, if there's no degree sign, it's automatically radians. You never label it RAD. Okay, we don't label that.
So how would you move it so it's in, like, so it's actually real when it's like in a different quadrant, right? Was it a different quadrant to add like 2 pi or 180 or just pi or that?
So does anybody remember what he's talking about? Brad, you remember?
I was making.
Oh, so he's asking about something about adding something to that formula?
Oh, adding pi,
Yeah, when do you have to add pi?
when it's in the second or third quarter.
Exactly.
So you don't have to do when it's in the fourth?
No,
First.
or the first, correct.
Can you go over the quadrant thing a little bit?
Which quadrant is which?
Yeah, or when to even know to apply the quadrant.
So the only time you have to worry about the quadrant is when you're finding the angle, when you're converting from rectangular to polar.
Okay.
Because the angle, the formula for the angle depends on the quadrant. If you're in quadrants 1 and 4, it's inverse tangent y over x. But if it's in quadrants 2 or 3, you have to do what Brad said. You have to add pi to it.
Okay.
So it's pi plus inverse tangent y over x. So I think those formulas we did on Tuesday. That would be 9.1. Actually, you know what? I think we did those Wednesday. 9.2,
All right.
the first part.
I gotta go about
Yeah, those formulas are all from Wednesday.
that.
Okay, so any questions on how to change rectangular to polar? So that's rectangular, and that is polar. Okay, so you're gonna have to know how to do that. And what else? Graphing. Okay, so we did a lot of graphing in polar. What were the things we graphed in polar today? The different shapes. Yep.
You did the butterfly, or the rose, right?
Yep.
Rose petal.
Yep, we did the rose petal thing. So that's, we're gonna change our mode to polar. And does anybody remember what the equation looked like for the, you can do 4 petals or whatever number you want.
Can't you do any number? You can do any number.
Yeah, you can use
Yeah,
various
yeah.
numbers and it'll change things, but you still gotta have the right setup.
The base, yeah.
You gotta remember what the setup is for the petaled ones.
Is there
A
it's
sine 2 theta?
That would be specifically for a 4 petaled, yep. You put in a number, sign, 2 theta. How many petals would that one have? 4, and how long would each petal be? 5 units long. Okay. If I do it as cosine, what's it gonna do to that graph? It's going to rotate it, and I think it's actually easier to see the length of the petals if you rotate it, because then you can just count. 1, 2, 3, 4, 5. You can see it clearly. Okay, so we studied that one. So that's a graph you want to make sure you know everything about, how you find the length of a petal, how you determine the number of petals, what an odd and an even number would do. So that was...
Petals is like, it's always one less than the number you put before the sine or the cosine, right? So I'd have 4 petals, right?
That one would have 4 petals, but what's the reason why? What number there is controlling how many petals?
Oh, it's the 2 theta,
The
right?
2.
So it's always double the amount of whatever you put in.
No, well,
Not always.
If it's an odd, it's the exact.
Yes, if it's odd, it's the exact number. If it's even, it's double. Okay, and then the number in front, that's the length of the petal.
So when it's odd, it's always that length, but when it's
That
even,
number.
that number, when it was even, it's always double that, right?
Yep.
Okay.
Denver?
So what about when that has a number in front of that? Like we're going to like 3 plus? Can we do that?
We never did one with a plus. You could try it and see what happens.
Oh,
So kind of changes, so the petals now are different sizes.
Looks like a fly.
Look at that, looks like a fly with giant wings or something.
mozzarella.
So we never did anything like that, but I could give you this equation and say, I just want you to graph it and tell me what it looks like. What else did we do? Graphs that we studied. So the petals.
Cardio?
Yeah, we did the cardioids. So cardioid, can anyone give me the formula for a cardioid?
Example with the sun.
Yeah, you just basically make that theta and make these two numbers the same. So actually a cardioid and the rose petal thing, it's not that much different, just changing a couple numbers around.
So cardioid is.
So that's a cardioid. And if you start to change this number, to do something like that, it's going to loop back on itself. So technically not a cardioid, but still a shape we kind of looked at. What else? I think there was one other shape we did.
Archimedes,
Yeah, we did the spiral. All right. So what's the equation for a spiral? You want to remember that equation? This is probably the simplest equation. Yeah, just r equals theta. Okay? And that means your radius is going to be the same length as your angle. The radius and the angle are always the same. So I could just try zoom 6 and see how it looks. Okay. What must my theta max be based on that picture? If I was in degrees, yep, it would be 360. But it must be 2 pi because I'm getting one revolution of the spiral. If I set it to 4 pi, I would get 2 revolutions, but it would go off the screen a little bit on the bottom and on the right. I'd have to adjust it. It'd probably go out to like negative 15 and 15, and I think, yeah, that would be good. You'd see everything. Okay, so you should have an idea of the spirals and how to graph those. What if you put a 2 in front of it? What would that do to the spiral? Yeah, now the radius is going to be double the length of the angle, so it's going to spiral out faster. It's not as, like we say, it's not as tight of a spiral.
So what if you put 1/2 in front of theta?
Then it would make it a tighter spiral. So it's going to spiral tighter. Yep. So the smaller you make that number, the tighter the spiral will be. If that makes sense. And I think that's pretty much everything. So there's a lot of graphing. So you need to know how to set theta mins, theta maxes, x min, x max, y min, y max, all that stuff. Okay. So any other questions or technology related questions? Yep.
So just for like those questions where it gives you the graph and then it gives you I'm assuming it gives you windows or whatever it is set that you have to find the one that.
Or they'd give you an equation.
Okay, yeah, or an equation.
Yeah.
So you don't need to actually write down the window itself. Like you don't need to like find a window that would. Those aren't the questions.
Well, there'll be different pictures drawn on the paper, and you'll have to match what my equation is to the picture on the paper.
Okay.
But it'll tell you what to use. It'll be very specific about how you should draw it. So all it's checking is, do you know how to type it in?
Yeah. And
If you know how to type it in.
But sometimes
Yeah.
it's like,
Yep.
Since I'm not going to be here tomorrow, I'm still going to do the homework. Is it okay if I give it to you early?
Sure. Yep. Okay. Any other questions?